You put some suitable values of x.
2.
Huh?
2. 2.
You put in x equal 2
Yeah.
and x equal to negative 1. If you put in x equal to negative 1 on the right, you will have b times negative 3. On the left, you will have 6. B is negative 2. You put in x equal to 2. On the left, you will have 3. On the right, you will have 3a. A is equal to 1. So the antiderivative of 5 minus x over x squared minus x minus 2 is the antiderivative of 1 over x minus 2 minus 2 over x plus 1 being ln x minus 2 minus 2 ln x plus 1. And then you evaluate that antiderivative at 7 and at 4. And that's it. Okay, on the second one, the degree of the numerator is 2, and the denominator is 3. You do a partial fractions. However, your linear factors are x minus 0 times x minus 0 times x plus 1. So you have a repeated factor of x minus 0. So the correct partial fractions for that would be
I don't know if I got the right values, but I did need that. I forgot.
a over x plus b over x squared plus c over x plus 1. Whose antiderivative is a ln x minus b over x plus c ln x plus 1. What is a, b, and c? You clear the fractions, multiply both sides by the denominator. On the left-hand side, you will be left with x squared plus 1. On the right-hand side, you will be left with a times x plus 1, b times x plus 1, c times x squared. We'll put some suitable values of x in there. I would recommend x equal to negative 1. X equal to 0, and you may choose any other third value you want. When you put x equal to 0 on the left-hand side, you will be left with 1, 0, 0, b. So b is 1. When you put x equal to negative 1, on the left-hand side, you will be left with 2, 0, 0, c. So c is 2. Using those values of b and c, we may rewrite the equation as that. now you may put another value of x in there. I will go with x equal to 1. This will be 2. A times 2. 2. 2. And you will get A is negative 1. So now we want to find the antiderivative of that. Being negative ln x, negative 1 over x, plus 2 ln x plus 1. Any questions? Okay, let us finish the partial fractions today. The last one we had was when you have an irreducible quadratic factor. When you have an irreducible quadratic factor, then there's nothing you can do. You just have to use a linear factor on the numerator. Let's take a look at an example. Let's say we have something like this. Now, this is a linear factor, and this is a quadratic factor a quadratic term that cannot be factored linearly using real numbers. So we have to just leave it. So what is the correct partial fractions? With such a rational function? Well, we could use a, well, this is linear, so that's nothing to do with it. It's just a over x minus 2. But this is irreducible, so you have to keep it. And what is on the numerator?
bx plus c.
Bx plus c. And you have to find the a, b, and c. And what does a over x minus 2 integrate to? A ln. And what does bx over x squared plus 3 integrate to? 1/2 b ln x squared plus 3. And what does c over x squared plus 3 integrate to?
C ln, or
1 over root 3 arctangent x over root 3. You'll have to look that up in your notes. Oh, remember it. Now it remains to find a, b, and c. We'll clear the fractions. We'll multiply both sides by this term here, leaving us on the numerator, on the left-hand side with the numerator. And when you multiply this by this, you will have a times x squared plus 3. And you will have bx plus c times bx plus c times x minus 2. Now you're going to have to put 3 values of x in, because you have 3 unknown variables, 3 unknown constants, a, b, and c. The easy one is x equal to 2. X equal to 2 is the easy value of x equal to x. When you put in x equal to 2, you will get what here? 21?
Oh, yeah.
And when you put in x equal to 2, you will get 7a. 7a is equal to 21. So a is 3. Now we need to put some other values of x in there. Let's try x equal to 1 and x equal to negative 1. When you put x equal to 1 here, you will get 11.
12.
12. That is to say, negative b plus c is negative 1.